we got to be really, really careful here. Where do I know that 1, 3 is? Well, I go over 1 and I go up 1, 2, 3, and that's the point 1, comma 3. It's in the first quadrant. Now, why is that important? Well, I'm going to show you here in just a second. We're going to use calculators. We're going to use all sorts of fun stuff. Well, once I have r, do you realize that I could use, if I'm trying to solve for theta, because remember I need an r and a theta, and I got r. I know what x is. I know what y is. That's kind of nice. And I know what r is. So I can use either of these. Or I can use tangent of theta as well, right? Couldn't I use tan theta equals y over x? So I'm simple country folk. I really like sine. Sine makes me happy. But I do have to be careful. I know that 3, which is y, I just grabbed the y value up here, equals r, which is root 10, times the sine of theta, right? Okay, so I know that this implies, that the sine of theta, let's see, sine of theta, equals 3 over root 10. I know that theta equals the inverse sine of 3 root tenths. Now, if you wanted to clean that up and turn it into 3 root 10 over 10, that's fine by me. I don't care. Now, here's where my spidey sense tingles, and a flag goes right up in my brain. It says, I know that the range of arc sine is from negative pi halves to pi halves. So I'm already thinking to myself, all right, whoa. I need to establish a quadrant, because if I end up with a point in either the second or the fourth quadrant, or the second or the third quadrant, that I'm going to have to do my fancy stuff. Remember how I had to add pi to get to values that I needed to get to, or I had to look at symmetric arguments. However, luckily, I don't have to worry about that in this case. All right, so what we're going to do is we're going to pop open my handy-dandy smart calculator. Let's do this in degrees. So I'm going to go to my mode, and I'm going to go, I got mine in radians right now. So let's go over, let's get an idea about degrees. And we'll go second quit. And I need to go second arc sine, or inverse sine, of 3 divided by second root 10. And I'm going to hit enter. 71 degrees. Look at that. So theta, let's change the color of my pen here real quick. So theta is approximately equal to, right? We got to be honest with ourselves. What is this? 71.565 degrees, which implies that 1, 3 in rectangular goes to root 10, comma, 71.565 degrees. Okay? Now, let's take a look back here real quick. Okay. 71.565 degrees. Well, look at this. Even with my crappy drawing, what we're saying is if we were to lay over a circle of radius root 10, ooh, that's a badly drawn circle, but that's okay. All right, so this right here is x squared plus y squared equals 10, right? We know that the radius is root 10. That would tell me that this angle right here is 71.565 degrees. And they're exactly the same point. It's so cool. I love it. Let's do one. I'm gonna import something real quick, so bear with me. Go over here. Let's import. Here we go. I'm gonna make this guy a little bit bigger, but not huge. And I'm going to center it out. Okay? It's going to be a little bit hard. My scale's a little janky here, so bear with me for a sec. All right, I got that. Okay. Let's do another one. But we're going to put this one, let's put it in the second quadrant. So I'm going to take the point -2, 4. Okay? You know what? I think I might like, I'm gonna, wait a sec, what am I doing here? I'm gonna pull this thing out so it's it's relatively squared away. Okay, that's better. All right, so we're gonna do 2, 4, and this guy is rectangular. So this is rectangular, and I'm gonna send it into polar, which is r, theta. All right. Now, -2, 4. So I'm going to have to use these little hash marks. So -1, -2. If I go along here, I'm going to get -1, 2. Oh, wait, you know what? That's not going to work. I'm going to go -1, 2, and then up 1, 2, 3, 4. So bear with me. 1, 2. I got to draw a little bit of a verb. Make a terrible drafter. I guess argue for your weaknesses. All right, so this point right here is -2, 4 in rectangular. Did you see what I did? I marched over. Let's change the color of my pen real quick. I marched over on this x-axis. I marched over -2, and then I simply marched up 4, right? Remember, this circular graph that I'm putting on here is just a superimposition over the top of the already existing Cartesian plane. But I'm going to rename this guy, and we're going to see how close we get. Okay, let's change colors entirely. Let's go to green, even though it's obnoxious. All right, so just like we did before, I know that -2 squared plus 4 squared equals r squared. So what's that? 4 plus 16 equals r squared. So r squared equals, excuse me, 20. So r equals, what is that, 2 root 5? Or square root of 20. Sometimes it's easier to think about as the square root of 20 because then it's a number between 4 and 5, right? Okay, so I got r. Sweet. Now all I got to do is come up with theta. Well, let's use sine again and watch what happens, because this can be really instructive. Well, I know that y equals r sine of theta. I've already got a y value. Remember, this is x comma y. So I know that 4 is equal to r, which is 2 root 5, times the sine of theta. So sine of theta, I'm going to switch this thing around. Sine of theta is, if I divide through, don't I end up with 2 over root 5, right? Because the 2 goes into 4 twice, etc., etc. So theta is equal to the inverse sine, that is an obnoxious color, of 2 over root 5. For some reason, I feel the need to vomit. All right, so watch what happens. I'm in quadrant 2. I know this for sure. I know that this guy lives in the second quadrant, right? This guy right here. But here's a problem. When I hop over to my calculator and I take the second inverse sine of, that did something funky, didn't it? Divided by second root 5, and I hit enter, what do I get? Oh no! I end up with theta. Oh, let's see. I end up with theta equals 63.435 degrees. Uh-oh, 63. That's a little bit bigger than pi thirds. Well, what do I do? How do I figure out the true value? Because I know that this is not a 63-degree angle. Heck, I got to go through 90 to get to this point. Well, I don't panic. I just remember symmetric arguments. Remember, I could either look at the function, or I could think to myself, wait a sec, I know that whatever happens with sine in the first quadrant happens with sine in the second quadrant. So this angle right here is 63.435 degrees, which implies that this angle right here is 63.435 degrees, right? Which tells me, oh wow, I'm using all my colors on the palette today, that this angle right there is going to be what? Well, it's going to be 180 minus 63.435. Remember that trick that we did back before when we were dealing with when we were brand new to inverse sine? And this is, whoa, goodness, this is going to tax me. This looks like 116.565 degrees. Let's see how good I am. 180. I love doing stuff in my head and then checking it, because when I get it right, I'm like, woohoo! And I don't always get it right. 435. But it's fun to try. Once it look at the big brain on Ripley, which implies what? -2, 4 turns into, remember this is xy, turns into what? 2 root 5, 116.565 degrees. Isn't that cool? That's a fun little piece of work. Okay? Now I know what you're saying. I know what you're asking in your head. Well, Ripley, we go from x's and y's to r's and betas. However, am I going to go from r's and betas? So, for example, ooh, I can't do that in red. Makes me feel satanic. However, are we going to go? I have to speak in my ridiculous southern accent. However, am I going to go from r and theta to x and y? Well, remember, I still only have x equals r cos theta, right? Y equals r sine theta. You're going to giggle at how easy this is. Tan theta equals y over x, and x squared plus y squared equals r squared. Well, okay, so pick a value. I don't care. Any value. I don't know. Let's go 4 comma negative pi sixths. All right? And we're going to turn this into x and y. R and theta. Hey, wait a sec. R and theta. Hey, wait a sec. R and theta. I've got it's tailor-made. I know that x is going to equal 4 times cosine of negative pi sixths, and y is going to equal 4 sine of negative pi sixths. Right? So let's see. What was negative pi sixths again? For cosine, negative pi, you remember it's root 3 over 2, right? It's positive root 3 over 2, so x is equal to 4 times positive root 3 halves, affectionately known as 2 root 3. What's y going to be? Well, it's 4 times what? Negative a half, isn't it? Negative 1/2, and I get negative 2. Guess what? 2 root 3 is my x, and negative 2. Now, whoa, but don't take my word for it. Let's go back here. Let's grab that polar coordinate graph again. Okay? Let me stretch this thing out just a little. Ooh, now it's superimposed. Oh, that'd be so nice to be able to do that, but I can't, unfortunately. All right, so here we go. You ready? First things first, let's plot 4 comma negative pi 6. So I'm going to go over 1, 2, 3, 4, and I'm going to go negative pi 6. Oh no, look at my graph. This only gives 11 pi 6. Well, so what? I'm not afraid of that. I know that 11 pi 6 is coterminal with negative pi 6, because if I subtract the 2, I get 2 pi. So I'm going to go over 1, 2, 3, 4, and I'm going to rotate it negative pi 6, so I go in the clockwise direction, and that's the point right there. Okay? Now, let's see what happens here. All right? My claim is that this point is 2 root 3. Let's see, what is 2 root 3? If I go 2 root 3 and I hit enter, I get 3.464. Let's see if that works out. So 3.4, let's change the color. You know what? I want this thing to be bigger. Let's make it bigger because we need to see what's going on here. You know, let's make it bigger. That's all right if we cover up some stuff. Okay, so sorry guys. One more time. Ooh, look at that. I can see through it, but I can't see my graph. So what did we do? We went over to 4, 1, 2, 3, 4, and down to pi 6. Now, this says that x is approximately 3.5. We can check that out. 1, 2, 3, and about 0.5. So I'm going over. Remember, it's just superimposed over the Cartesian plane. So this is approximately 3.5. And y is negative 2. So if I go down 2, right, and I climb over, and I climb over, and I end up right where I need to be. That is the point. Now, granted, my scale's a little bit off, but I got a little bit lazy here with my values here. This is the point, 2 root 3 comma negative 2. Isn't that fun? That's a hoot. Well, listen, that's about all you need to be able to do these guys. Going from polar to rectangular is a piece of cake. Going from rectangular to polar is a little bit nastier. But it's so fun. And the cool thing is it just comes from these 4 simple little rules that I can apply and apply and apply and apply over and over again. So enjoy, have fun with it, and I'll see you in class tomorrow. Okay? Bye-bye.